technically our last topic for extension 1. I'll come back to probability. It's not hard. Where are we? That's 2-unit probability. We're trying to look at 3 units right there. Permutations and combinations. Who has started this at school?
Me.
We did it at the beginning.
I started.
Yep, at the beginning, Mariette. Who else? Sorry?
We did it at the beginning too.
Yep. Okay, then maybe the better question is, who hasn't done permutations and combinations?
I haven't done it.
We're nowhere near it.
Emily, Anouk.
I haven't done it.
Is that Andy? Is that you?
Yep.
Yep, so 3. Okay. Well, for those who have done it, who can say they are good at it? Just good. Yeah, I know, right? It's an annoying topic, which is why it's done at the end. So look, with permutations and combinations, it is either a 0% or 100% topic. So you either get it or you don't. And I was personally one of these guys. So I was the ones that didn't get permutations combinations very well. I neglected it for a while until I had to obviously get it to this stage, which for me was more towards year 12 and wasn't in year 11. So it's okay if you're struggling with it at the beginning, but I think the idea is try not to neglect it like I did, because eventually you will have to get it to hit anyways, because you obviously want to. So while you've got the time in year 11, you might as well spend the time on this to perfect it. There is a trick. Obviously, there are tricks between the questions, which I will teach you, which obviously wasn't taught to me, which I'll teach you to hopefully make your life a little bit easier with the different styles of questions. The questions themselves are not, I guess they're not repetitive. Like, you're not going to get the word triangle again. You might not, right? So it's not, you're not going to look at the exact same question. Whereas, like, let's say, I don't know, with calculus or with trig or with exponentials or whatever the topics were, they were usually pretty repetitive. The only topic that wasn't repetitive should have been rates of change. The first bits of rates of change, the dr on dt, we split that up to dr on dv times dv on dt. Those rates of change weren't repetitive in the questions, whereas the exponential growth and decay questions, these are repetitive in nature. So these ones are pretty easy. These ones are not so easy. Permutations and combinations are the same thing. So the questions are not so repetitive, so unfortunately they're going to feel a little bit confusing at first. Until you expose yourself to a lot of different questions, then you start to realize, hey, there's a pattern. If I've got dr there, then dr's there. If I've got dt there, then dt's there. As long as these two are the same, then usually cancel out. This is usually given to me in the question, blah, blah, blah. So you start to learn how to answer the questions, even if they are different. All right, so for those who have done it, the reason why it feels a bit confusing is because it's like that. Hopefully, second time round, third time round for some of you, I think maybe it should be probably now the third time, should be even easier. And that's the idea. So when you walk into your exams, you feel like, yep, piece of cake. All right, let's start with permutations. So a permutation is when order matters, or order is important. Let's just write that, is important, and a combination is where order is not important. So it's more of a counting technique. We're trying to count how we can place things in a certain way, or how we can list something in a certain way, or how we can arrange something in a certain way, and then it's just dependent on if order is or is not important. Now, the thing is, a permutation, you're not going to see me use the letter P. Now, just so we get used to P and C on our calculator before I continue, for those who haven't done this topic, it is on top of your times and divide button. So if you press Shift times, you should see a P. Try that out, press Shift times, and then Shift divide should give you a C. And you can see it says NCR and NPR. So pretty much that's your permutation, that's your combinations. Now I'm trying to say I don't really use the permutation button. It's just not the method that I follow. Whereas for combinations, we will use the C button. Any questions at this stage? Okay, when I say I don't do the permutations, that means your teachers usually do permutations, okay, because they're following the textbooks, and the textbooks do follow it through using the P button. What I personally use instead of permutations is factorials. Factorials are the exclamation marks. They're on top of the log, I think. Is that right? Yep. On top of the log. LN. Can we, everyone identify that? Factorial button? So please don't mix up the two techniques. I mean, if you look at, obviously if you look at, you know, I don't know, your textbooks examples, or if you look at sometimes exam papers and they're doing it through permutations, I personally don't use permutations. I use factorials. I understand them very well. I know how they work. Permutations sometimes confuse me, especially with the more trickier questions. So I pretty much ignore permutations. All right, so be careful when you're trying to, I guess, relearn this or restudy this, or when you're looking at exam solutions. I don't personally use permutations. For those who've done this and they're comfortable with P's, please continue. For those who have done it with me and have done factorials already, please continue. And obviously for the others that haven't and are going to learn the factorials, and if it makes sense, then great, stick to it. Don't learn the P. Any questions at this stage? All right, so a factorial, just before I finish off and get started here, a factorial is, I think the easiest way to say factorial is obviously just 5 times 4 times 3 times 2 times 1. In other words, you start off at the 5 and you keep decreasing by 1 until you get to 1. And it's just multiplying. So your calculator does that for you. I think the answer should be 120. If you did like 3 factorial, it's just doing 3 times 2 times 1, which is 6. Does that make sense? So if we look at a question 1, how many ways can 7 different colored marbles be arranged in a row? First, you've got to realize, is this a permutation or a combination? Right? So does order matter or order doesn't matter? Well, if there's 7 different colored marbles, I always tell you to draw a diagram. So let's draw 1, 2, 3, 4, 5, 6, 7. 7 different colored marbles. And then of course, if you've got 7 marbles in a row, order would matter, because once you pick one goes in here, you've got less to go in here. Then you've got less to go in here, and less, and less, and less, and less. In other words, you've got 7 marbles that can go in the first position, you've got 6 that can go in the next, and so on, and that becomes 7 factorial. Anouk, does that make sense? Andy?
Yeah.
Cool. All right. Obviously to others, I'm assuming because you've done it, they shouldn't be too difficult to understand at the beginning. How many 8-letter words can be made by rearranging the letters of the word triangle? Well, first thing you would have to look out for is, are there any repeating letters? There isn't, so that would just be 8 factorial. Or in other words, if you had to draw it up, 1, 2, 3, 4, 5, 6, 7, 8, I could pick 8 letters, then I could 7, then 6, then 5, 4, 3, 2, 1, that just becomes 8 factorial. Mariette, I know you've already completed this booklet, which is good, so therefore these should all be at 100% for you as well. So for those who have completed this booklet, I really want this to be at 100. All right. How many 8-letter words can be made by rearranging the letters of the word nonsense? What happens this time if we're trying to answer A? 8-letter words. So 1, 2, 3, 4, 5, 6, 7, 8. And there's 8 letters. What's going to happen? What's the problem?
Because there are 2 letters that repeat.
There are a few letters that repeat, would you say, yeah?
Yeah.
So there's like N that repeats, S that repeats, E repeats. You can't say, oh, there's 8 letters that go in here, because there aren't 8 letters. So if I was to say, I don't know, let's say N. If I say that was N, well, which N did you choose? Did you choose that N, or that N? Does it even matter? So really, let's say there's only one N, then there's one N, then there's like one O, and then there's one S, and then there's one E. You know, there's technically 4 different styles of letters, let's say. So because we've got that logic, and it's a lot harder to do what I was just saying there, what we say is if there are repetitions, we're trying to divide them out. We try to take them out. So what you would do, you do them normally, 8, 7, 6, 5, 4, 3, 2, 1, whatever. I think we get the idea of that. 8 factorial, when then we divide it by the repetitive letters. So we try to take them out because they're not unique. So 3 factorial for the 3 N's, 2 factorial for my 2 S's, and then 2 factorial for my 2 E's. So if there's ever a repetition, we have to divide it out. And there has to be a repetition if they're exactly identical. It's very important that we understand that. So if I said there was a boy, girl, boy, girl, boy, girl, boy, girl, 1, 2, 3, 4, 5, 6, 7, 8. If I said there's boy, girl, boy, girl, boy, girl, boy, girl, boy, girl like this, I want to arrange them again to make it in a row, just like this, or whatever. Well, what would the answer to this case be?
Eight factorial over 4 factorial times 4 factorial.
Incorrect. See? And that's why we hate this topic. It's not 4 factorial and 4 factorial. Why? Can someone tell me why it wouldn't be that? And it actually is this.
Because it has to alternate boy, girl.
No, incorrect. I just did that on purpose. Why don't we divide? Maybe Maria, you want to give it another shot. Why don't we divide now? Now that I've said it's not dividing. What's the difference between this style of question compared to obviously the one just on top?
Because they're people and they can't repeat.
Yes, that's it. See, and that's where I was saying between the 0% to the 100%. It's just if you either get it or you don't. So you guys got to understand. Unfortunately, with this permutations and combinations, if you really want to say, hey, tick, I know this topic, you've got to expose yourself to the different questions. And just one slight little bit changed, and it changed the answer completely. So you can't really memorize. You really got to understand what's happening. Now, let's have a look at it again. So question 3, N. Is there a difference between this N and this N? And this N? Is there a difference? And that's the key word. Would you answer yes or no to that? Is there a difference between that N, and that N?
No.
Well, no, not really. I don't know. There's no difference. They're just N's. Is there a difference between this boy, and that boy? Is there a difference between these 3 boys?
Yes.
Well, you would assume so, right? Even if they were twins, you would still assume that they are different in one way or another. Cool? So in this case, you've got to understand it should just be 8 factorial because there are no repeating factors. All right. Let's keep going. How many of these, and we'll see all these questions, don't worry. B, how many of these words would have E's as the first and last letter? Okay, the trick to it, 2, 3, 4, 5, 6, 7, 8. Anyone other than Maria can tell me that's completed this. What do we do when the questions are worded like this? How many of these words would have E's as the first and last letter? What's the method?
Don't you put the E at the front and the back, and then you deal with the 6 in the inside?
Absolutely. So you actually technically ignore the E's. So you put them there. So there's your E. You want it at the beginning? There it is. You want it at the end? There it is. Then you ignore it. And then, of course, how many letters do you have left? Like Lucas just said, 6 factorial. I think we get that. We watch out. How many of these are repeating? Well, the N's are going to be repeating, and the S's are repeating. Any questions at this stage? Anouk, make sense?
Yeah.
Now watch this. This is how I can make it different. I go E1, E2. Would have E's, E1, E2 as the first and last letter in any order. In any order. What would you have to do this time? To this. What do we think, you guys? So now they're different, right? I made it unique. E1 is obviously different to E2. Or it could have been what? E2
Factorial
and
times factorial on the top.
say again, times it by?
2 factorial.
Absolutely. Times it by 2 factorial, because these could change positions themselves. Good. Good. We get that? See how it changes if they're unique? So if that was, again, boy and a boy, you still have to times it by 2, because the 2 boys can change. All right. Good. Good, good, good. All right. Question 4. I'll leave that one for homework. It's pretty repetitive. We'll come back to it if we're having any issues. All right. Question 5. In how many ways can 4 girls and 3 boys be arranged in a row so that the girls are always together? Okay. Again, for those who have done it, what do we do when someone's going to be together?
So the 4 girls would be like a unit.
Yes. So the 4 girls are one big unit. That's the trick there. So when something's got to stick together, or if they're not going to stick together, you probably still do the same thing. So something we learned last week, if something's not together, you will do, I don't know, you will do the total combination. So all possible combinations or probabilities or whatever it is, all possible combinations, minus them together. So always think of the complementary events. So not together is equal to all possible combinations minus them being together. Just like if I was to say, what's the probability of it not raining? You would say 100% minus the probability of it raining. Something like that. All right, continue. So when the girls are together, you keep them as one big unit. And then if you think about as these girls move, you can move like this. You know, or like this. Or like this. Something like that. So they move together, technically. So the answer would be, well, this is, I mean, you guys just saw, I can move it in 4 factorial ways, right? You just saw that. So that's going to be done in 4 factorial, or you read it as this, 1, 2, 3, 4. So these 4 can be arranged in 4 factorial, multiplied by, what about these girls?
4 factorial.
Can't they move? Yeah, can't they move as well within themselves? They're still going to be together, times 4 factorial. Do we all get that? Again, Please tell me if I'm rushing, if I'm going fast. Last thing you want with this topic is to assume you know it and you have a question. Anyone have any questions? The girls and boys are in alternate places. Okay, if they're in alternate places, I think you guys saw what I did above. 3, 4, 5, 6, 7. That will be a girl, that will be a boy, that will be a girl, that will be a boy, that will be a girl, that will be a boy, that will be a girl. And then it's pretty easy. It's just 1, 2, 3, 4. The girls have to be in 4 factorial, and the boys have to be 1, 2, 3. 3 factorial. They can only move in 6 different ways. So that's 3 factorial. This boy could move here, or this boy could move here, or vice versa, and so on, until you get 6 different ways. And that would be the answer there. You just plug it into your calculator, right? What do we reckon? Any questions? If this is making sense with factorials, then forget about permutations. See how we haven't used them yet? Everything's making sense with factorials, then why do you want to go learn permutations? Just stick to it. Unless, like I said, you understand permutations, good on you. Keep going. That's good for you. Right? But if you guys understand factorials as well, great. Keep using this. Whatever works well for you. Let's do question 7, and then we'll see how we go with time, and we'll come back and do the other ones. Sorry. Question 6. Let's do question 7. All right. There are 4 identical red marbles. 4 red marbles. 3 yellow, and I think the important word there is identical, right? Because now you know it's not yellow 1, yellow 2, or yellow 3. They're identical. Anyways, 2 green marbles. How many different arrangements are possible? Well, 4, 5, 6, 7, 8, 9. 9 factorial, and then divide by my 4 factorial, 3 factorial, 2 factorial. Do we understand why I just divided there? They're the same marble. They're the same marble. They're the same marble. Identical. Yep. How many different arrangements of just 5 marbles are possible if the selection must contain all 3 colors? All right. All 3 colors. 5 marbles of all 3 colors. So can someone give me an example of what could happen?
Would we use the choose button here?
You don't. You would not use the choose. You'll see when to choose. You'll see when to choose. You'll see when to use choose. I think the wording is going to be a little bit different, and you'll see that in a second. But can you give me an example, Anouk, of how you can have 5 marbles and they have to contain all 3 colors? Give me an example of one case.
You got 2 green marbles,
2 green,
2 yellow,
2
1
yellow,
red.
1 red. Good. So what you've already understood from here is, hey, this is going to be a cases question. You've got to run through the different cases. Case 1, case 2, case 3, whatever. Because you can't just get it out. It's not going to be like, oh yeah, 9 factorial, you're done. It's not going to be like that. So you got to run through the different cases. All right, so let's run through all the different cases. So Anouk just gave us 2 green. Where are we? 2 green, 2 yellow, 1 red. Then maybe you'll go 2 green, 1 yellow, 2 red. Then you'll do, is there any other case with 2 green like that? 2 yellow, 1 yellow, 1 red, 2 red. No, I don't think so. Right? I think that's it. If I'm not wrong, if anyone else can see anything for 2 green, let me know. I don't think I can. So I'm going to now go with 1 green, 2 yellow, 2 red, 1 green, 2. Nope, that's it. Oh yeah, 1 green, 3 yellow, 1 red, 1 green, 1 yellow, 3 red. What else? Am I missing anything else? I'm sure there is. Anybody else see anything that I've missed? 1 green, 1 yellow, 3 red, 2 red, 1 red. I think that's it. I think that's it. Can anyone see anything else? All right then. Then you've got 5 marbles. 2 are green. So obviously that's just going to be 5 factorial, 1, 2, 3, 4, 5, over the 2 repeating ones. 2 factorial, 2 factorial. 5 factorial over 2 factorial, 2 factorial. 5 factorial over 2 factorial, 2 factorial. I think we get the idea. This one, 5 factorial over 3 factorial, and then same thing as this one, 5 factorial over 3 factorial. So in other words, the answer is 5 factorial over 2 factorial, 2 factorial times 3, 1, 2, 3 cases, plus 5 factorial over 3 factorial times 2. In the answers, I've got you a different set of answers. I'm sure using permutations. When I send you guys this booklet, and if you want, you can do it that way as well. And it's fine. But to me, I just think this makes it simple. It makes sense. It's clean. Any questions? Novak, this makes sense? Would you have done cases, Novak, when you going to read question 7b? Would you have thought of running through the cases? Not there. Mariette, what about you? You've done it. Did you know this was a cases question?
Yeah, we've done these kinds of questions in class,
Good.
and my teacher with these ones would get us to write down the cases.
Yeah, that's really good. To recognize it is the hardest thing. Just to recognize. All right, let's have a look at. There it is. You guys can see all the different cases here. But anyways, let's look at some combination questions now. Okay. Combinations. How many ways can a committee of 4 be chosen? Choose. Right, chosen from, so combinations, from 6 men and 4 women if there is no restrictions on the selection. So you know that there are 10 people altogether, and you're trying to choose any 4 people. It doesn't really make a difference who they are, how many there are, as long as there's 10 people to select from, and we're choosing any 4. And then you just plug it into your calculator. Let's make sure everyone knows how to use this. You should get 210. And Diana, you said you haven't done it, so just make sure you're able to plug that into your calculator. 10C4, shift, divide, and then 4. All good? All right, done. There must be equal numbers of men and women. Okay, again, who can tell me what to do here? I'm sure you know what needs to be. Sorry?
Is it another case question?
I agree, right? It's probably another cases question. There you go. You've already started to realize what to do. Yeah, this would be another cases. So give me the. I think there's only 2 cases, or maybe even 1 case. Yeah, only 1 case.
Isn't there only one case?
Yeah, there's only 1 case. I was thinking there's only the 1 case, but that's okay. That's just a 1 case. It is, I guess, cases, but there's only the 1 case. Lucas, tell us what's the case.
Well, one case is there's 2 women and 2 men.
So
it's
how would you
6
choose that?
Well,
Yep.
6 choose 2, and then 4 choose 2.
And then do I add that?
Times.
Because you got to get 6 choose 2 out of 6 men. You have to choose 2, and means times. There's 4 women, and you have to choose 2. But there's only the 1 case in this instance. And then whatever that gives you in your calculator. Again, I've got answers all at the bottom, so I'm sure you guys can just copy that down later on. Question 2. How many ways can a committee of 3 be chosen from 5 men, 8 women, if there is no restrictions? If there's no restrictions, then again, I've got 13 people to pick from. I'm just going to choose 3 of them. It doesn't matter. There has to be at least 2 women chosen. At least 2 women chosen. Okay, so what are we going to do? This will definitely be cases now. And Anouk, you want to give it a shot? At least 2 women chosen. So give me a sample of how it's going to work.
8 women, 5 men.
8. So you got 8. Choose what? 8
5.
women. So you say 5?
Oh, no, 8 choose 3.
8 choose 3. That's allowed. Yep. So they're all women.
Yeah.
Yep, that's fine. And then all.
Wait, how big is the committee? 3?
Yeah, the committee is maximum of 3. So therefore 8 choose 3. You're done because that's it. You can't have more than that. And that's 3 women. Or what could you have done?
8 choose 2 plus 5 choose 1.
Not plus. Times.
Okay.
Be careful. Plus is this bit. Or so you could, this event, or this event, or this event, or this event. That's when you're plussing. If it's an event with the same event, you have to multiply. So you have to have 8 women. You choose 2, and you've got 5 men, and you have to choose 1.
Yeah.
Does that make sense? The way the plus is?
Yeah.
Good. And then again, plug that into your calculator, plug this into your calculator, and done. Do we all understand the different cases that we just did? Again, for those who've done it, hopefully this is getting even easier now, second time round. Which is what we want. A group of 3 men and 7 boys include a father and a son. A group of 3 men and 7 boys include a father and a son. From this group, a team consisting of 2 men and 2 boys is to be chosen. How many ways can the team be chosen? Well, that's very easy. How many ways can you select 2 men and 2 boys from 3 men and 7 boys?
4 choose 3 times 7 choose 2, right?
4 choose 3 times 7 choose 2. Where did you get 4 and 3 from?
Oh, no, it's meant to be 2, right?
And 3.
Yeah.
So 3 men, and you're choosing 2, and 7 boys, you're choosing 2. Yeah, that makes sense. Yep, we all agree with that. 3, you're choosing any 2, and then 7 boys, you're choosing any 2. See how that's a bit different compared to if I had said, actually, let's just keep it there. From this group, a team consisting of 4 is to be chosen. What would the answer be? What would you say in this case then? From this group, a team consisting of...
Yeah, 3 choose 3, because you can't have more than them. And then 7 choose 1, right?
Nope. I want 4. Who can help him out? A team
10
consisting
choose 4.
10 choose 4. I agree. Because now there's no restriction on who these people are. It doesn't say there's a boy or a man or anything like that. So I've got 10 people, in other words, and I'm just selecting 4. So you see how the question can change just slightly, and obviously the math changes. And look, makes sense what I'm saying with that now?
Yeah.
It doesn't matter who you're selecting. So do you have any questions there for that case? All right. How many ways can the team be chosen if the father and son cannot be on the team together? So sometimes it's easier to do it as cannot. Sometimes it's easier, like I said, to do it as can be in the team together and then subtract. So I think this one, I can see it's just easier to make him in the team together and then just subtract. So if they are to be in the team together, how many men do I have left? How many men do I have to select from? Sorry, how many do I have to select from? 2. How many men do I still need? 1. How many boys do I have to select from? 6. How many boys do I still need? 1. And then I'll work that out. I'll quickly do that. 2C1 2 times 6. C should be 12, but anyways, 12. And then 3C2. Let's do that one real quick. That gave me 63. So in how many ways can they be chosen if the father and son cannot be on the team together? Answer would be 63, take away 12. Okay, so sometimes it's easier to do it as cannot, and sometimes the complementary event is actually easier. And again, that just comes through a bit of experience. You'll learn when most of the times it's the complementary event. But then there are some times where the complementary event is as long as just doing it like this, so you might as well have done it as cannot. But anyways, that makes sense. What I've done there, I've included them, so I can ignore them part of the calculations for the next man and boy that I've got to pick. Yep. Question 4, pretty much the same as question 3. I'll leave that with you guys to do. Okay. Then we just get to a whole bunch of random examples. And the biggest one here that you want to learn is the circle case. Circle case. I've got to remember to do the pigeonhole principle as well. Circle. So with circles, the idea is if I've got 1, 2, 3, 4, 5 people around the circle, because I don't know, with a circle there is no starting point. So if there's no starting point, the problem is I can't exactly start counting. Whereas in the fact when it was a row, I know this is the start and this is the finish. So it's easy for me to count. I can go 1, 2, 3, 4, 5. Here, I don't know where to start. So what we do is we let someone go. They can sit down. They've chosen that particular seat. It's gone. I don't have them anymore. And then I've only got 4 people left. So 4 factorial. In other words, for circles, it's always n minus 1 factorial. So if I've got 5, you take away 1, 4 factorial. Okay. There are cases where You've just got to watch out. And I'll see if there's some in here. Imagine you had a necklace, and imagine I had the letters Sam as little blocks, and then I was going to put these letters in through this necklace and then make a word, make a 3-letter word. All right, you know, you guys know I could have made mass, I could have made Sam, and I think we get the idea. You could have made sma, whatever words. In fact, there's 6 words I could have made. Right, 3 factorial, 6 words. So in a case like this, in a necklace case, you actually do have order. So it's not a circular case. Right? So it's not an n-1 factorial. It is just a 3 factorial. So you got to be careful sometimes with these, or like a bracelet. They do those kind of questions, unless the word's already there. Now, if the word's already there, how many ways can these move? No, I've got to think about that. I've got to think of a question if the word's already there. Will come to me. But yeah, I'm sure we understand this case here. I'll look at some few others once as we do questions. So let's have a quick read of question 3. In how many ways can the letters A, E, I, B, C, and D be arranged in a circle? The best thing I can keep telling you guys, always try to draw or act it out. 1, 2, 3, 4, 5, 6. So I think we know 2, 3, 4, 5, 6. You ignore 1, so the answer to that is just going to be simply 5 factorial. That's how many ways they can be arranged in a circle. How many of these arrangements have at least 2 vowels together? Okay, so you want 2 vowels together or 3 vowels together. Right, so 2 vowels or 3 vowels. Or you could have done at least 2 as no 2 vowels together. No 2 vowels together, and then subtract from the original. Do we understand that you could have done either? So again, I've got to show you guys this because some of you might look at your solutions and they've done it this way, but then you would have thought of these two. Some of you would have looked at your solutions and done it this way, but then the answer says to do it this way, but they're both the same. You just got to stick to whatever your logic tells you. I'll do both just to confirm that both methods work and how it works, but just so you know, you can do either one. So if the 2 vowels are together, you group them, then this can't, so imagine that was an A and that was an I. Oh, that's just going to be a lot harder. Because then you got to choose A and I, and then you got to choose E and I. Whoa, this method's going to be hard. Why? No, it's not that you can't do it. It's just that the fact that you got to go with A and I, or you could have done E and I, or you could have done A and E, and then they're going to change. So you could have done A and I, E and I and E. So that's six combinations there. Yeah, I think that's just going to confuse you guys. I'd rather not do this one yet, if we don't have to. So let me see. No 2 vowels together. No 2 vowels together would be this. If there's no 2 vowels together, that means that would be A. Then the next one would be a B. Then it could be an E. Then it could be a C. Then it could be a I. Then it could be a D. 1, 2, 3, 4, 5, 6, 7. I drew 7. 6. And then you guys can probably see no 2 vowels are together in other words, is like an they're alternating. It's an alternate question. So to be able to do this, just like we did above, we would do 1, 2, 3, but then you would have to cross one of them out, right, for a circle. So 1, 2, 3, and then 2 factorial. So for no two vowels to be together, it would be 3 factorial times 2 factorial, which is 12. And then for it to be at least 2 vowels together, the answer is 120 minus 12, 108. So for me to have gone and done that with 2 vowels or 3 vowels, let me see if I can get it out for you guys. If anyone have any questions with the method I've done here? No, that kind of does make sense, yeah. All right, let's see if we can get the same answer. 3, 4, 5, 6. Okay, 2 vowels together. So the 2 vowels of the 3 choose 2. 3 choose 2. 1, 2, 3, 4, 5 times 4 factorial. So 3 choose 2. And then 4 times 4. Okay, plus 3 vowels together. 3 vowels together. Well, that can only be done in one way. But no, but then these two can change as well. So times, no, but I've already included that. But I'm going 3, choosing 2. Yep, times 4 factorial. And then if the 3 vowels were together like this, I would have said these guys can change within each other, which is 3 factorial times 3 factorial. All right, let's see. Let's see if the math adds up. I don't even know. So 3 choose 2 times 4 factorial is 72. 72 plus, what's that? 3 factorial times 3, 6 times 6, 36. Oh, we got it. All right. All right. Who's got some questions for me? This way. You see how much more confusing this is? But who understands what I've done with either 3 choose, I mean, who doesn't understand? 3 choose 2 times 4 factorial with the 2 vowels. Come on, I'm sure there's someone.
Yeah, Sam, I don't get it.
Yeah. Okay. What about the 3 choose 2? What do you think I've done there? What did I start with? Novak, tell me.
You chose 2 vowels together
Out of?
out of 2 spots.
No. I had 3 letters, 3 vowels. And I'm saying if I can only have 2 vowels, out of the 3 vowels, I need to pick any 2. How many ways can I do that? I can do that in 6 ways. So 3 choose 2 is 6. Right?
Okay.
Or if you can't do that, if you don't know the 3 choose 2, or if you don't understand that for any reason, you could have also said, well, that's A and I. Right?
Yeah.
But I could have also had A and E, and I could have also had
E and I.
and I. But then these could have swapped positions. So there's 1, 2, 3 times.
Times 2. Okay, because it
And that still
switches.
gives
Yeah.
you 6.
Yeah.
Again, that's another method. You could have just done that. See how
Okay.
many methods there are, and that's the problem. Like, you know, let's just say Cambridge does this, Fitzpatrick does this, Matthew in Focus does this, and then Sam does something else. Okay,
Yeah.
so but they're all the same. You guys got to just work out what makes the most sense to you. But anyways, so that up to there, that makes sense, right? So I've done that. I've chosen the maximum combinations as possible in that little box there.
Yeah.
Then, how many different groups do you have now?
4.
Why?
5.
Because it's 5 minus 1.
Yes, so that's it. 5 and then minus 1, 4. So 4 factorial. Plus, if I wanted the 3 vowels together, here it is. My 3 vowels together. How many ways can you rearrange these 3?
3 ways.
3 ways. So 3 factorial. Is that what you meant by 3 ways? Or because there's 6 ways.
Yeah.
Wait, be careful. 6 ways or 3 factorial ways? So be careful with that. Do you agree that it's 3 factorial?
Yeah.
Okay, yeah. So 6 ways again, because 3 factorial becomes 6. But anyways, but see, this and this, even though they're the same answer, they both gave you 6, right? If you
Yeah.
try it out. No, they don't give you 6 actually. 3 choose 2 is 3 ways. Ah, right? 3
Yeah,
choose
it's
2.
3. Yeah.
It's only 3. Ah. Why? No, I didn't even think like that. I just use choose because I know that's just the way I do it. How many ways can the letters? Let me think. Why is my logic there wrong? E and I, A and E, A and I. How many 2 vowels together in a circle? E and I compared to I and E. Well, it doesn't really matter. How many of these arrangements have at least 2 vowels together? If you want 2 vowels together, as long as you've got E and I don't even know why times 2 doesn't work now. But if I was to draw it, if I had done it this particular method, I probably would have done times 2. But I just decided to do choose because it makes more sense to me. But I'll come back and see what my logic there, why it's wrong. Here, 3 factorial, 1, 2, 3, 3 different ways. And then again, how many groups do you have? 4, take away 1, 3 factorial. So, does this one make sense?
Yeah,
Now?
yeah, I get it now.
Now I'm stuck with why this times 2 doesn't work. So why am I wrong there? Let's think. I've got 1 and 2. How many arrangements have at least 2 vowels together? So if I've got E and I, but that's different to I and E. Why am I not going to go 3 times 2? 6. Why am I not going to do that? Why is it that I did do it here? 3 factorial. This could be E, I, and A, or A, I, and E, or whatever, 6 different ways. So how come this one's a 3 choose 2? I guess that's how you do it. You do 3 choose 2. You've got 3 letters, 1, 2, 3. You're choosing any 2 out of those 3. And the other one doesn't really matter. Whereas in this case, you're not doing 3 choose 2. You're rearranging E, A, and I in 2 ways. Yeah. Look, the difference between the 2 questions, if I had, so, I don't know if you guys get it right now, but let's see. Let's go down here for a second. I've got A, E, and I. I've got 3 letters, and I've only got 2 positions. How many ways can I put 3 letters into 2 positions? Compared to, I've got 3 letters make a word into make a 2-letter word. Make a 2-letter word. Verse. Okay. Do we see a difference between the 2 questions? 3 letters into 2 positions. Compared to, I guess, 3 letters, you're trying to make a 2-letter word. If you've got 3 letters and you're making a 2-letter word, then this word would be obviously different to this word. So this one would be 6. Whereas if you had 3 letters into 2 positions, you're only going to have the AE case, the EI case, and the IA case. You just want to fill any 2 positions out of your 3 letters. So permutation, combination. Permutation, needs to be a combination question. So that was my logic for that. But I thought by making it simpler, I could show you guys this, but I just realized by the time I times it by 2, I'm making it relevant. So unfortunately, it becomes like this worded style question, which is not what we want to do when we're selecting positions for the circles. So unfortunately, when I'm going to do it this way, it doesn't really work the times 2. It's just going to look like that. But yeah, I tried to make it easier for you guys, but it looks like I shot myself in the foot there, so it didn't work out. Because that becomes a permutation if that. All I'm trying to do is just select any 2 vowels to go in. All right. But you can see another way you could have done it was the complementary case. All right, let's try. They're the same. In a straight line, in a circle. So that's the same, that's nothing. In a straight line, I'll leave that with you guys. Rectangular table has 6 seats, 4 being on one side. Yeah, that's the question, Nate. A rectangular table has 6 seats, 4 being on one side next to the kitchen and 2 being on the opposite side. So draw it out. 1, 2, 3, 4. 1, 2. In how many ways can 6 people be seated at the table if 3 people must sit on the same side? So 3 people must sit A, B, and C must sit here. So how would that work? What do we reckon? 3 people must sit here. Or they don't have to sit next to each other. Actually, let's make that point clear. They just must sit on the same side. Or it could have been something like that. Or it could have been like this. Or it could have been C here and then A here. So what do we reckon when I'm doing all this? Anyone have any ideas of what they would have done? 3 people must sit on the same side. Alright, maybe I'll give you guys just a little bit more thinking time. Just think. What would you do with a question like this? Is it a circle question? Don't think so. Definitely some rows. How do we take it into account?
Well, the people on one side.
Say that again. Sorry. Say it again. Start again.
The 4 people sitting on one side.
Yes, 4 people on one side.
They would be 3 factorial because they can change.
Wait, one more time. So there's 4 people on one side, and that can be arranged in 3 factorial ways.
Yeah.
4 factorial. 4 people, sorry, in 3 factorial ways.
3 factorial times 2 factorial.
Oh, because of this?
No, because like never mind. I've confused myself.
I'm trying to think about it as well. Hold on. Yeah, that's okay. Wait. 4 people, 3 factorial. 4 people in 3 factorial ways. Okay, so if we're stuck, always revert back to your basics. We've drawn it out. Like I said to you guys, go your A, B, C, then, I don't know, let's say there's D, E, and F. Yeah, that's the other 3 people. Right? So what, it could have been A, B, C, D, could have been A, B, C, E, or could have been A, B, C with F. So that's something you guys got to remember. And how many ways can these guys be rearranged? Well, A, B, C, D, and then with, like, let's just say this would be E and F here. So A, B, C, D would be 4 factorial. So you had the right idea. Not yet. So 4 factorial, and then these guys could change within themselves 2 factorial. Or what could you have had? You could have had A, B, C, E. And then this would have been what? D with F. So again, you would have had 4 factorial times 2 factorial, and then the last one, this would have been F. That's what I tried to show you guys with them moving. I was hoping that you would realize they would be 4 factorial definitely times 2 factorial, and then that should give you the answer that we're looking for. Who's confused? Okay. Tell me what part of it you don't understand. Let's start again. There's 6 people. A, B, C, D, E, and F. And then it's saying that there are 6 people seated at the table, and there's obviously 4 on one side. 1, 2, 3, 4. Don't try to do this without drawing it. It will get confusing. Okay. And it's saying 3 people must sit on the same side. So what's the first case, Anouk? Well, can't it be like this? Can't it be A, B, C, and then D here? Or can't it be, let's just use D for a second. Or can't D be here and then A go here? And then can't D be here and then A go here and then B go here, and so on and so on and so on? So what's another way of arranging A, B, C, and D in a row? Well, don't you have 4 letters? So isn't that 4?
So it's 4 different.
Yeah, do we get that?
Yeah, so it's 4 factorial.
And then how many letters, how many other people do you still have? You've got E that can go there, F that can go there, or F that can go here, and then E that can go there.
So 2 factorial.
Times 2 factorial. Do we get that?
Yeah.
And then you could have done that with, not with A, B, and C, and D. You could have done that with A, B, C, and E. So therefore, this guy becomes D and F. Or you could have done that, or you could have done this one down here with A, B, C, and F, such that the top guys become D and E. A, B, C are still together. Do you get that?
Yeah.
So in other words, we're going to times it by 3.
Okay.
Does that actually make sense now?
Yeah.
All right. And times by 3, because of the 3 cases, you could have also done this, for those who want to be fancy. 4 factorial times 2 factorial times, well, you know the one case. Now you know that up here you have 3 letters to pick from, right? Sorry, 4 factorial times 2 factorial times, you've got the 3 letters to pick from to go into 2 positions. You could have also done 3 choose 2, which still gives you 3. So it's the same math. But anyways, it depends on your logic. I think the second one, this first one that we did makes more sense. B. A and B must sit opposite sides. Okay, we start again. Rub it all out. And start again. A and B must sit opposite sides. Again, those who have completed it, you can see, even though you've completed it, it's still not perfect. Because the questions can change just slightly and it gets a bit harder. A and B must sit on opposite sides. Well, again, there's two cases. There's this, or there's obviously this. Do we all agree with that? So let's consider, well, let's just consider this case right now. B and A. So if A is to be here, A and B must be on opposite sides. You're gonna have 4 people to pick from that can go into here. And then these guys can be arranged in 4 factorial times 2 factorial would be like that. That's what I would have done. So exactly what I just showed you above, I would have done the ways times the factorial, and then I would have added it to the other way around. So times it by 2 times 2. I'm pretty sure. Let me just double check my answer. Question 8, B. Question 8, B. Consider A on the long side. 3 people join yep ways. Do my factorial. Similarly, should be right. We'll find out. It shouldn't be wrong. All right, let's have a look. Question 8. So again, I'm choosing this particular case where A is here, B is here. First thing I've got to do is understand these guys are gone. How many people do I have left? How many people can sit here?
3 people.
So that should be 4. I've got 4 people to pick from. I'm going to choose any 3. So this can be done in 4 ways. Do we agree with that? There's 4 people to pick from. But I've got to choose 3 that can sit next to A, and then whoever's left can go here. So in other words, if you guys want to play the game, you could have had C, D, E. This must be F, or it would have been E here and then F, or it would have been D here and then E and F, or that's 3, or the last one is if C was there and then D, E, and F are there. Do we agree with that? Can you see what I meant by the ways? That's it. You can only have 4 people. You're choosing 3. So there's only 4 ways of this occurring, or you could have played the game and worked out. That's the number of ways to rearrange whoever's left. Do we agree with that? I hope you guys can learn it the way I'm showing it to you, because it's probably the easiest way you're going to see it. That's 4 ways. Do we agree? Anouk, you agree? Novak, what do you reckon? Does that step first make sense?
Yep.
Okay, you got to think like that. How I'm thinking, you got to start thinking like that. Exactly the same. You put A and B on opposite sides. You think, okay, now we've got 4 people left. We'll choose 3 positions here, and then the person's going to sit at the end. Well, it doesn't really make a difference. Or you can play the game, and you'll still see there's 4 ways. Now, what do you got to do to those 4 ways as well? Well, you know that A, D, E, and F, what happens? What happens within each row here, Novak? A, D, E, and F. No? Novak?
4 factorial.
Yeah. these guys can move in 4 factorial ways. Times, these guys can also move in 2 factorial ways.
Okay.
So don't forget, you've just placed them in there. Like you placed D, E, and F in here. But who said D has to be here, E has to be, F has to be there? Why can't F be here, E be here, and D be here? So first, out of these 4, you've got to put them in. Then once you put them in, you've got to also say they can change. Who said A has to be here? What if A was in here somewhere? You know, so you can keep changing. So that's 4 factorial, and then there's obviously these 2 left on the top as well that can change. That's it. That's for A being down here and B being up there. And then if it was the exact opposite way, if A was up here and B was here, you just times that whole answer by 2. So hopefully, if I've done it right, it should give us the answer that I saw. 2 factorial times 2, 384. Yes. We are good. There's a lot of things happening. The math is simple. To write this, I mean, to copy that down is nothing. You're copying nothing. It's knowing what I've done. It's really hard. What do we reckon? Emily, Shania, what do you girls reckon? Queenie. What confuses you? So I can go again. Sometimes maybe it might not be even confusion. It might just be, I just need more exposure. 4, we chose out 3, that's 4 ways. Then these guys can change 4 factorial ways. And these guys can change 2 factorial ways. Then I can change my A and B times 2. Do we understand that? All right. There's no questions. We'll try C. B and C must sit on the side next to the kitchen. So that means that B and C must sit here. So that's similar to A. Let's see, again, we'll draw it out. 1, 2, 1, 2, 3, 4. B and C must sit on the side of the kitchen. Again, I'll give you guys some time to think about it. Let me also think about it, and we'll do it. B and C. Okay, so I've got to do that. 2 people. We need to join, so we're going to do that. Then it's going to be that, that. Should be fine. All right, who wants to give it a shot? Very similar to what we've been doing. B and C. Who's left? A, D, E, and F. Who wants to give it a shot? How many ways can I rearrange? Can I place? I'm just going to stop. Who wants to give it a shot? All right, I'll pick someone. Let's try Lucas. Lucas, you want to try it? What would you do?
Well, so you deal with the condition first. So B and C have to be on one side, and
Yep,
whatever you place, regardless of the other ones, it's going to be 4 factorial on one side and 2 factorial on the other side.
I agree. So I like that. So you're saying I don't really care about, regardless of anything else. You definitely know these guys are going to move in 4 factorial ways. I agree with that. And these guys are definitely going to move in 2 factorial ways. I also agree with that. So you can see the math hasn't changed from A and B for that bit. So yes, these guys can move. But now you've got to select people that can sit here. And how would you do that? And that's pretty much, you're done.
You mean in those 2 spots specifically? There's 4 options to choose 2, is that what you're saying?
That is exactly it. There's 4 options. You've got A, D, E, and F left. And then you have to choose 2 people. Doesn't matter what 2 people. And that can be done in, technically, 4 choose 2 is 6. That can be done in 6 ways. If you guys want to play the game again, if there's A, D, E, and F, go and try to put it into these 4 spots. And you'll see there's only 6 ways that that's going to happen. So either going to be AD, AE, AF, DE, DF, or EF. So AF, AD, AE, DF, DE, or EF. 1, 2, 3, 4, 5, 6. 6 ways, or 4 people in the choosing 2. I can sit here. That's what it's doing. The combinations. The order doesn't matter. It doesn't matter if it's AF or FA, because you're going to include that in your 4 factorial. Them moving around. And that should be the answer, I think. So 4 choose 2, let's see, 6 times 4 times 2, 288. $288. All right. All right. Let's see what we're up to. I'd like to do some more. What's left? Let's try to do the pigeonhole principle. All right, let's stop there. Actually, I had some other stuff I want to go through. Let me see what I've put in here. Factorial, there's a quick notes. I think we get that. Next question, 7 how many ways? Okay, yeah, that one. See, I knew I had it somewhere. Okay. So if there's a necklace, very simple. There's 7 beads. How many ways can I arrange 7 beads on a necklace? Remember, you have no starting point. Or what would the word be? You don't have a starting point. So you know definitely that's going to be 6 factorial. You don't know what the letters are or anything like that, so that's 6 factorial. The problem is with a necklace, it can be read from from left to right, or from right to left. From left to right, or it can be read from left to right, or obviously from right to left. So the problem is you're going to get words that are repetitive with it being in a necklace. So another way to also think about it is that a necklace can be flipped. And if a necklace is flipped, so if I had the word Sam on this side, right? If I flip it, if I flip the necklace, you would see mass, but then mass would have already been included in your when you were going to change these words around. Do we understand what I'm saying there? So remember that Sam case? There was 6 combinations, right? Sam, mass, and smart, whatever. But then if I flip the necklace, well, then you're going to see again mass, or you might see, if it was Sam, you'll see mass. If it was something else, you'll see, if it was SMA at the beginning, then you'll see AMS, which was already included part of your calculations here. Because a necklace can be read frontwards and backwards, you've got to divide that by 2 factorial, or by 2. So that's what I was trying to get to. Necklace questions, they're very unique. You've got to do 6 factorial. They're like circles, but because they can be read both leftwards and rightwards, or frontwards and backwards, however you want to say it, you got to divide by 2. So that's just something I want you to make a mental note of. Just this specific question, you've got to divide it by 2. That's it for that one. That's something I don't forget. And then let's do some of these annoying factorial style questions. Okay, let's do it. All right. Now we've got to learn how to use factorials properly to I guess for algebraic questions. So they've got nothing to do with so much probability or anything like that. You can see I've labeled them miscellaneous questions. They're just more random style questions. So the first thing is we've got to go back to the original formulas. So NPR and NCR. These can be written in terms of factorials using this formula. And choose should be this. If I'm not wrong again, let me just make sure. Yeah. So NPR, permutations, is actually factorial and combination is also a factorial. The only difference between the two is that this one here is dividing out whatever you're choosing. So technically dividing out your repetitive factors. But anyways, n factorial over n minus r factorial, NCR is n factorial over r factorial n minus r factorial. So let's just get something clear. So if I have npr plus 1, the way we write this in factorial form is n factorial over n minus, now r plus 1 factorial. And then we get n factorial over n minus r minus 1 factorial. Anyone confused about that? It's a little bit more algebraic compared to the whole probability or permutations and stuff. Let's just look at another one. If I said n plus 1, c r plus 1, this would be n plus 1 factorial, right? The top one factorial, the bottom one factorial, so over the bottom one factorial, then these two subtracted. So n plus 1 minus r plus 1, but don't forget when you're going to minus it, it's going to be minus r minus 1 factorial. n plus 1 over r plus 1 n minus r factorial. All right, at this stage, is there any questions? Novak, what do you reckon? Feeling okay with this?
Yeah, I get that.
So algebra is fun. All right, let's look at a question like this one here. Okay, simplify. N minus 1 pk plus k times n minus 1 pk minus 1. And don't forget, NPR is n factorial, n minus r factorial. Okay, I might give you guys just a minute just to write this down. Maybe write down what you would have done in your first line using the formulas. And then I'll give it a shot as well. All right, let's do it. So, n factorial, n minus 1 factorial over n minus 1 minus k factorial plus k times n minus 1 factorial over n minus 1 minus k plus 1 factorial? Anyone got something different? Then at this stage, you're just gonna, because there's a plus button, the simplifying means just make it into a common denominator. That's pretty much all you're gonna do. And I'll tell you the trick to it. Don't have minus 1 minus k. Usually put your numbers at the end. They'll be easier to see. You'll realize that in a second. So k and then n minus 1 factorial over here. Your minus 1 and your plus 1 cancels, and you're left with n minus k factorial. All right, at this step, any questions? Any questions?
Do we have to simplify it over a common denominator?
You have to, yeah. That's usually the idea. So keep in mind that 6 factorial is 6 times 5 factorial, right? Because technically 6 times 5 times 4 times 3 times 2 is the same as saying 5 factorial, which is 5 times 4 times 3 times 2. Or you could write 6 factorial as 6 times 5, then times 1 less, and then factorial. 4 factorial can be written as 1 less, and then factorial. So what I'm trying to show with that is, if you ever had something factorial, you could leave it as it is, the number, multiplied by 1 less, and then factorial. So we need that because to find the common denominator between these two, you can see if I took away 1 from here, right, because 1 less, if I take away 1, I'm only going to get minus 2 or minus 3, minus 4. That's not going to help. But if I took away 1 from here, if I get minus 1, that becomes the same as this denominator. So watch. And that's the trick to these questions. You always look for the larger one. This is the larger one. Because when I write this, n minus k factorial can be written as n minus k, and then you take away 1 factorial. Just like I wrote here, 6 factorial is 6, take away 1, 5 factorial. Or 5 factorial can be 5, take away 1, 4 factorial, or 4, take away 1, 3 factorial. So n minus k factorial is n minus k times, take away 1 factorial. Okay, any questions at this stage? Next line. What's my common denominator? Well, has to contain all of your denominators, right? So it's got to be n minus k and n minus k minus 1 factorial. Then for those who've done their fractions the way I've taught you, you just ask yourself what's missing. So what's missing from this denominator and these two? You're missing an n minus k, so it looks something like this. N minus k and then n minus 1 factorial. So you multiply the top by the n minus k, in other words. Plus what's missing from these two and these two, nothing. So you don't times the top by anything. So that just becomes k n minus 1 factorial. Again, I'll stop there. Any questions? Is anyone confused?
Can we expand the top?
I am. I'm just. Anyone confused? Nope. All right. Let's expand the top. You say, how do we expand the top?
Yeah, because with the factorial, how do you expand the top?
That's just like you saying that's a. And this is, I don't know, x minus y. You would have said ax minus ay.
Okay.
So it's the same. It's just normal algebra. You could have done that, or you could have factorized n minus 1 factorial out. Doesn't really matter. I'll expand, since I think that might be a bit easier. So n minus 1, n minus 1 factorial minus k n minus 1 factorial. Do you see something that just happened now? The denominator, just so you guys know, right now this is written as, let's say this, 6 times 1 less. But don't forget, I can just write this as 6 factorial now. Now that I know what my common denominator is and I fixed it all up, my numerator, the bottom, I'm just going to simplify it back to this. So the denominator is this. If you didn't have to, unless it helps for our numerator, I will find out. But you didn't have to. You could have left it as that. That's fine as well. Just thought I'll show you guys. You could simplify it again back to this. These two cross out. Minus k plus k. And no, it's done. You can't simplify this any further. So that's it. n minus 1 factorial over n minus k factorial. This would be worth 3 marks. Extension 1. Prelims. It's going to come up. n minus 1 factorial over n minus k factorial. n minus 1 factorial over. Okay, any questions?
Sam,
Yes.
I don't really get the expansion.
At which stage?
The expanding part at the bottom.
The expanding part at the bottom. Here.
Where you expand the
So
numerator.
yep. So again, I guess the best way to look at it is, imagine this was x minus y, and this was just like a. What would you have done if you had to expand this? This term multiplied by the x, and this term multiplied by the y. So pretty much that's what I've done. N minus 1 factorial multiplied by n. There it is. Minus k times this.
Oh, okay, yeah.
You see that now? Plus, and that just stays the same. So, yeah, it's probably the best way to look at it. Just this times this times this. Again, you didn't have to simplify the denominator. You won't really lose marks for that. There you go. Anybody else have any questions? All right. Let's see what else I've got here. N factorial as if I didn't realize that. Oh my god. I didn't realize n minus 1 is n factorial. Too busy looking at the denominator, forgot the numerator. Isn't the top n factorial? So n and then 1 less. There we go. N factorial, n minus k factorial. So this just became n p k. That's what we just proved. We proved this thing n minus 1 pk plus k times n minus 1 pk minus 1 just becomes back to your permutation. n minus 1. Should have kept an eye on that. All right. Question. All right, let's try one more. Again, I'll let you guys get started on it. Solve for n. Solve for n. The formula is n factorial over n minus 3, in this case, factorial, for NPR. So let's see how you guys go with that. My clue is you've got to break up your numerator so that you can get rid of your denominator. That's a clue for you guys to start thinking about.
Sam, does that say 20n?
20n, yeah, that does, yep. Equals
Okay.
20n. Okay, my turn. Let's see what we came up with. N factorial over n minus 3 factorial equals 20n. All right, well, definitely you're not going to be able to solve if you're going to have your factorial there. So we've got to get rid of that. So the logic's going to come back to that 6 factorial that I was just saying. 6 times 5 times 4. Let's say you can keep going until, until something's nice. And you can cancel it out. So n factorial will be n minus 1, n minus 2, n minus 3, I found it, and then just before you stop, factorial. Anyone not understand the logic of this? Equals 28. No, we're good. Then I'm just going to continue. N squared minus 2 minus 1 minus 3n plus 2 equals 20n. N cubed minus 3n squared plus 2n minus 20n equals 0. N cubed minus 3n squared. Okay, what do I do now? I'm going to solve for n.
Factorize the n.
Factorize the n. N minus 18, I'm going to choose 6 and 3. So negative 6, positive 3. Therefore, n equals 0, 6, negative 3. Anyone have anything to add? Especially from those who've done this topic. Anyone have anything to add? But what?
Sam,
Yes.
I think I got rid of the n in front of the brackets.
You by cancelling them out from both sides.
Cancelling. Yeah.
If
The
you
and then
technically you got rid of a solution, right?
yeah.
So if this was another day, another question, not part of permutations and combinations, you would have not written 0. So then you would have lost a mark.
Okay.
Learn not to cancel. Always factorize.
Yeah.
So same as this question. Sine theta cos theta equals cos theta. If you got rid of cos by dividing both sides, you just got rid of one solution. You got rid of a solution, whereas what it should have been sine theta cos theta minus cos theta. You factorize. Look, you got cos theta equals to 0. You got to do that, and you got sine theta equals to 1. You got to solve that. So be careful with dividing. The only time you ever divide if it was sine theta equals cos theta. You don't get rid of a solution, you create tan. That's fine. Any other time you should not be dividing. You should be, if you're solving, you shouldn't be dividing, you should be factorizing. So yeah. Unfortunately, you would have got rid of a solution. But anyways, anyone else? But n.
Is it a -3?
But n has to be greater than 0. Isn't n the number of people you're going to pick? You can't, I mean, or you don't have 0 people. You don't have -3 people. So n is just 6. You can't have n here being 0. You can't have 0 people and let's say you're picking 3. You can never have, anyway, this is always going to be greater than 0. And you definitely can't have -3 people. So you guys got to remember that. As much as the math works out nice and simple and whatever, you got to keep context in mind. So the answer is only n equals to 6. There you go. That was an exam question. That's why I've got it here. Try that one out. NP4 equals to 840. From what I can see, I'll give you guys a clue again. From what I can see, I think this becomes a polynomial division question. So there you go. I made this one into a polynomials question for you guys. So to complete this, you need your polynomial stuff. So try that out. Don't get lazy with it. I'm trying to combine topics because that's where you're at now. Last one. I think this is the hardest one I could have made. Prove. Let me just make sure I've got everything right. It's 2n factorial. Is the whole thing right? In brackets. So 2n factorial equals to 2 minus 1, 2 minus 2. All right. Let's see if we can prove this. Prove. Prove. All right, so we're going to start with our left-hand side. So 2n factorial, so that becomes 2n minus 1, 2n minus 2, 2n minus 3, 2n minus 4, ... until you get to pretty much 5 times 4 times 3 times 2 times 1. That's what factorials do, right? You keep decreasing by 1 until you get it down to, 4, 3, 2, 1. Same thing with n factorial. That's n minus 1, n minus 2, n minus 3, all the way down to, again, 5, 4, 3, 2, 1. So a lot of students usually are able to get that line out, right? They're just going, oh, factorial just means this. That's fine, but then a lot of students can't see how to prove the right-hand side now. Can someone tell me something that they see? Something that they see in the right-hand side, and that's a skill. It's a really hard skill to pick up, but it's a skill that I've been trying to teach some of you guys for a while now. What I have, what I need, how do I get there? What I have is this, I have this, I need this, and then obviously how do we get from this line to this line? Well, first you got to ask yourself with this need bit, what's different to what I've got? What's the biggest difference to what you've got? What would you say?
It's a fraction.
Yeah, I would say so too, right? I'd definitely go, well, how come I've got a fraction? There's no fraction here. So I like that. So that's let's put our thinking down. Fraction. So I'm already thinking like that. I got to get rid of the fraction. Cool. What else do you see? I see something else as well. What else do you see? Look at it properly.
It hasn't been factorized.
Hasn't been factorized. Do you mean like these brackets?
Yeah.
Because there are. The brackets are here. You just can't see them.
Okay.
That's why they gave you only the last one. But there's something else. Just keep looking at it one more time. So fraction, I agree. There's something else that's very different from, I guess, what I've written here.
Off with the numbers.
Say that again.
It starts off with the numbers, like
Again, I can just change these around. That's not a big problem. I mean, here I could do 1, 2, 3, 4, 5. You're getting close. It is something to do with that. But I could rearrange them. I mean, that's not a big issue.
The ends
Well,
at the bottom don't have
Wait,
twos.
sorry, Mariette, what'd you say?
The ends at the bottom don't have twos.
Okay, wait, say that again. The ends at the bottom.
Yeah, there's no
Don't have
two. Like it's
twos.
not 2 and it's just n.
Okay, I like that. That's going to be part of the solution. So hold on. The bottom doesn't have twos. That's good. That's part of the solution eventually. But look, I think, and you're one of the ones that I've trained enough to know to start looking like this. So I like it. And it's always good to get things wrong. Like, it's good to try it out, because you got to understand this skill, it takes some time. But sorry, Lucas, now what were you saying?
Well, 1, 3, and 5, they're all odd numbers.
That's the
If you
second.
put any odd number into n, put any odd number into n, it turns into an even number. So
Wait. Say it again. That you put any odd number
like if
into.
you substitute a value of n for like
Yes.
2n factorial, it will always become an even number, regardless if it's odd or something. That's what I don't understand that part.
Not really. Oh no, yeah. Wait. What? You confused me. You're saying 2n factorial. If I sub in an odd for n, which is 1, that gives me 2. If I sub in 2, 4 factorial. Okay, fair enough. 3, 6 factorial. Yeah.
Oh, is it the like how it goes 1 times 3 times 5? It's in
Yeah.
the thing it's 5 times 4 times 3 times 2.
Yeah, right. The fact that this one here, which I thought you had it, and I think, Lucas, is what you were trying to say, but you were trying to say that this becomes even all the time. I don't think you need that fact. It's more that you can see what we're trying to prove here. These are only odds. Where's the evens? What happened to 2, 4? 2, 4, 6, 8, 10? Who do we appreciate? That one. Where is it? It's not here. And that pretty much combined with maybe what Mariette said here, the bottom doesn't have 2s. If you put all of these 3 things maybe together, we're about to get the answer for this. There's no way that you can learn that other than by you guys going, this is what I have, this is what I need, how do I get there, and start thinking about it like this. It's a skill. It's not something you're just meant to learn from one day and then that's it. It doesn't work like that. Because that can be applied in any topic at any stage. So yeah, the fact that these are odd and a fraction. Okay, so this is going to be my thinking. I go, okay, odd and fraction. Okay, Maria said there's no 2's at the bottom. And odd. Okay. I think I can do something about it. Well, the top, the numerator, right? What if I... Yeah, because there's your 2n minus 1, right? What if, I go, okay, take out a 2 here. 2. I took it out. What do I have left? N. All right, well, there's your 2n minus 1. What if I took a 2 out of here? Out of all the even numbers, what do I have left now? N minus 1. Then 2n minus 3. Then if I take out a 2 from this guy, I'll have 2 and then n minus 2. And what if I keep doing that? So 5 and then, well, let's say to the 4, I did it as 2 and then times 2. And then 3. And then the 2 is just a 2. And then there's a 1. Wait, do we understand what I just did with the top line? Essentially, I said that the bottom line doesn't have 2's. So what if from the top line, I decide to factorize my 2's, but I can't factorize my 2's from everything, because these odd ones, you can't factorize the 2 out. Only from the even numbers, you can factorize the 2 out. Are we with me at this stage? Because I'm very close to getting the answer. Everyone's with me at this stage? Yes? Someone confirm? All good?
Yep.
All right. Good. Then this is what you're going to do now. No fraction, right? That was the next thing you said. No fraction. So watch. They're all multiplied. N minus 1, n minus 1, n minus 2, n minus 2, n minus 3, n minus 3. Somewhere here you would have had 2 times 5, right? Because you would have had the number 10. The 5 and the 5 would have cancelled out. Let's say you would have had 2 times 4, which is 8. The 4 and the 4 would have cancelled out, and so on and so on. So pretty much everything cancels out. The only thing that 2 cancels out, this 2 cancels out. The only thing you're left with on the top is what? A whole lot of 2's. A lot of 2's. 2, 2, 2. Again, 2, 2, 2, the 2, 2, 2, 2, 2. A whole lot of 2's. How many 2's do you have? Then look at the answer here. What does it say? You have 2 times 2 times 2 times 2 times 2 times 2. How many 2's? 2 to the power of n multiplied by, and I think we all can see our answer now, 2n minus 1, 2n minus 3, dot, 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 5 times 3 times 1 equals right-hand side. Boom. That is like what we say state ranking question. It's not a band 6 or something. That's a state ranking. To be able to execute that, you really need to know how to do this. I have this. I need this. How do I get from what I have to what I need? And then working out a lot of things, like there's no fractions, the fact that they're odd, the bottom doesn't have 2's. All of this comes into play. And saying answers like this is good. It's fine. Let it be wrong, but at least say it. And you'll see. Sometimes what you'll say doesn't make sense. Sometimes what you say will make sense. Voila. All worked out. All right. Talk to me. Obviously very different. Does anyone have any questions? That makes sense now. So a whole bunch of 2's, and then of course just whatever's left, which is all your odd numbers now. All right, right on.